This is tutorial 8, question 9 from Lay's 5th edition, page 295, question 1. In this question, we are given B, a basis consisting of 3 vectors, B1, B2, and B3, and D with 2 vectors, D1 and D2. We are told that the transformation goes from an element in V into W, the vector spaces, where V is constructed with basis B and W is constructed with basis from D. We are also given this information, the linear transformation of B1, B2, and B3 according or with respect to the basis of D. So in fact, we have all the information to construct the matrix of linear transformation from the basis T to P. Where can we find this? Let's now refer to Lay's. This is Lay's 5th edition, page 291. In this section 5.4, it will introduce the linear transformation matrix. Now this picture figure 1 here shows the vector space V and the vector space W. And the element X is from V being transformed by T, the linear transformation, to this element T of X belonging to the vector space W. Now, we also know that X can be represented in the B basis, and this is X B, the coordinate vector in the B basis. This is the notation. The bracket with the B as a subscript showing that the elements of X, for example, X1, X2, and X3 are the coordinate vectors of the vector X in the B basis. In Lay's book, he uses the element R1, R2, and R, for example, up to N as the elements for the X coordinate vector in the B basis. What does XB mean? Basically, it means this. The coordinate vector are scalar, that it will be multiplied by the basis. So this whole bracket thing here represents X. So this is X, and XB are simply the scalars associated with the basis B1 to Bn to represent X. Now, when we apply T, the linear transformation on X, because T is linear, well, if we represent X in this way, and seeing that R1 to Rn are scalar, then we can actually bring R1 outside. And because the operation is linear, we can act on each individual R1, B1, R2, B2 independently up to Rn, Bn. And therefore, what we see now is transformation of X can be represented as this equation. So at this point, we observe this equation is here. Now, we want to represent it in the C basis. So this is what we do. We take the element T of X, which is in the vector space W, and we represent it in the C basis. Now, representing it in the C basis is a coordinate mapping, and this is linear. So we look at this equation and see that simply again we observe that R1, R2, and up to Rn are constants. The change of basis is only affecting TB1 to TBn, and we'll see that the vector from the TB1 change to the C basis. Finally, the whole system of transformation can be represented simply by a matrix from XB to Tx in the C basis with respect to the multiplication matrix M. M is this matrix. TB1, TB2, and TBN in the C basis. Alright, so now let's go back to our question. In our case, this is the input X in the B basis. This is the matrix of linear transformation from the B basis to the D basis. Observe the arrow. Some people prefer to write it this way, doesn't matter. And finally, M times XB will change the input from the B basis. In our example, it is the D basis. Now, the input is three-dimensional, R3. The output is two-dimensional, R2. So M must be a 2 by 3 because X is a 3 by 1 and Y is a 2 by 1. So let's work this out together. We have to find these elements over here, TB1, TB2, and TB3, and then change it into the D basis. What is TB1? It is already given to us, 3D1 minus 5D2. In fact, the question has already told us that TB1 represented in the D basis is simply 3 minus 5 in the D basis. Similarly, TB2 is equals to minus 1 plus 6 in the D basis. And TB3 is equals to 0 plus 4 in the D basis. Therefore, the matrix M is simply equals to, we take this column, and this column and put them together. This is the answer. Right. I'd like to clarify why I say that this guy is actually TB1 in the D basis. Okay, so we start from this equation over here, and it is simply we can express this as TB1 is equals to D1 D2 multiplying by 3 and minus 5. Let's just call this the D basis matrix. This guy is X in the D basis. This guy is TB1 in the standard basis. So this, if you remember the equation, to change from the standard basis into the D basis, this is the transformation. Okay, and therefore we can see that this blue box here is actually the TB1 in the D basis.